So this is the force on inclined plane, the theory part. Friction is a resistance force acting upon an object that stops or reduces the body's slippage comparative to a second body or surface it is in contact with. This force often works tangent to the surface at about bodies. It is opposed to the body's actual motion relative to these points. In this experiment, the block has the potential to slip down a plane when a block is put on an incline. If the inclination angle is poor, the friction between the surface keeps the block from sliding. When the angle of inclined plane increases, the force acting on the block increases and the force pushing the surfaces together will reduce. The force that works down the plane only to overcome the friction and slipping occurs at the angle of friction. So this is the illustration of the theory of force acting on an inclined plane. This picture shows the free body diagram of an object that is on an inclined plane. The P is the frictional force acting upon the object, the S is the X component, and the R is the Y component, where S is W sine theta and R is the W cos theta.
Hello, Assalamu alaikum. I am Tariq Aziz Patori, metric number 81600002. We are from group 4. So today I'm gonna present the result and calculation of friction on an inclined plane. So here you can see the result. We just calculate the applied force on different degree. You can see for test 3, 4, 5, 6, 7. We just calculate the experimental and for calculation the applied force. This is our result. After that we calculate the coefficient friction. So this is the formula you can see in the slide. The coefficient friction is that sine theta by cos theta equal to tan theta. So just use the theta, so we can get the coefficient friction for test 3, test 4, test 5, test 6 and test 7. This is the calculation you can see in the slide. Another one is we just calculate the weight block W. So this is the formula. P is equal to W sine theta plus mu W cos theta. So before we calculate the coefficient friction for each test, so you can see the applied force, also the coefficient friction. We just calculate from the table. So we derive the equation equal to W equal to P by sine theta plus mu cos theta. So if we put all the values in this formula, we can get the result. You can see in the slide, we just calculate for test 2, test 3, test 4, test 5, test 6 and test 7. So this is the another slide. We also calculate the W also for test 5, test 6 and test 7, and all the value we get from the table, and the coefficient friction we before calculate you can see in the slide. So that's all for me. Thank you very much.
Good morning to my lecturer. Today I'm gonna present about friction on an inclined plane. My name is Diko, metric number CD180195. I'm going to present about the discussion that we have made in the lab experiment. We were given 3 questions on the discussion part. First question A is discuss the value of P obtained by experiment and calculation. Compare those values with force P with force S acting down the plane. Overall, the value P obtained by the experiment are less than the values of P by calculation. Suggest some reason why there are differences occur between the values of P by experiment and value of P by calculation. Both value of P by experiment and calculation increases when the angle of inclination of tan theta increases. Lastly, state the differences between friction on the horizontal plane and friction on the inclined plane. Okay, the frictional force acting on both cases will be the same of nature, acting in direction opposite relative to motion, but the value of forces will vary in both cases. This is due to the fact that frictional force is directly proportional to the normal reaction. Hence, the normal reaction in both cases will be different. So the final value of forces will be different. That is all from me. Thank you.
So, throughout this whole experiment, there are a few things that can be observed. It requires a certain value of angles to make the block to slide down the plane. Second one is it needs a certain number of loads to make the block to slide up the plane, depending on the mass of the block. If the mass of the block is higher, then it will require a huge amount of load to make it slide up. So the third is the block started to slide down slowly before it gained speed in the test 1 but not in the test 2, because the test 2 is the block going up. So it will be a sudden move. The conclusion for this experiment is the concept of friction itself and friction in an inclined plane really benefits us in our daily life. Friction provides our shoe soles grip to help us to climb inclined place or to walk on a slippery fall. Friction in automobile provides grip to the tires to have a better driving performance and avoid accidents and fatal. The main point is that friction provides a lot of advantages to us and to the industries. Remember when doing this experiment, always make sure to put the load slowly to avoid confusion in the results. So that's all from me. Thank you.